Good morning to everyone. Thank you for all being here. Today we're going to talk about the idea of coherent routing or building a purpose-built multi-layer node for the network, specifically working from layer 0 to layer 3. We've been talking about this concept for several years. This idea goes back actually decades of how we would address IP optical convergence. As time has moved forward and technology has become more innovative, we've been able to find ways to reduce the cost and increase the performance to find a sweet spot in order to converge these technologies together like we have never done before. So we're going to just go through a few key factors of consideration when constructing a purpose-built coherent router. First, we're going to talk about the impact on operations. It's not just about the router itself, it's also about the tools, the processes, and the practices to maintain the network. As we move forward then, we would also like to talk to you about evolution and total cost of ownership, the investment strategy that's taking place here, life cycle management. And then third, sustainability has been a very clear objective across the board in our industry from top to bottom, what we can do in order to create a very sustainable, energy efficient, eco-friendly infrastructure. So first, we're going to break down operations. Now, this graphic actually comes from a paper that was written probably 8 or 9 years ago for the data center. HFS did an article on the evolution of automation in data centers. And some of the terminology that was used and is still used today, IBM kind of coined the phrase robotic process automation. And then HFS came up with the intelligent automation continuum, kind of showing the advancement of automation in the data center. Now, if you look at the black text here, you can see access, assembles, and structured data performing specific prescribed actions. That's very similar to some of the things that we've talked about. The next layer is about conducting calculations for predetermined actions to be taken. And then the more advanced phase is really about intelligent processing. And if we map that to some of the concepts that have been discussed for service provider networking, we see some similarity with automate for task simplification. And then we have advanced policy. You can think about how we do that in routing. And then finally, what our dear colleague Caridi always calls self-driven networks, right? Self-learning, self-healing. And then we also have different standards that we've all been collaborating on in order to make the programmable network infrastructure, leveraging technologies that are interoperable and open, that help us kind of move forward to create an end-to-end, open, and eco-friendly network, okay? So far so good. The operations pieces, it seems as a community, we are working kind of together to solve a problem at the higher layer. It's not a question of why are we doing this anymore. It's not a question of what are these concepts. We've kind of graduated to the level of how can we most efficiently bring these to the market, right? Next is the idea of task simplification. When we build our purpose-built coherent router, it needs to work in a way that we can do fault isolation and troubleshooting in the way that is we're not trading off anything that we had before. So therefore, that means the ability to do fault isolation and troubleshooting on the router should function as it does traditionally on a router. And that also means that the fault isolation and troubleshooting we do on the transponder works the way it has been traditionally done on a transponder. We should have the same parameters, the same look, the same feel, the same terminology, so that we do not confuse people in network operations, especially when we're working in hybrid brownfield networks. So we need to be able to do things proactively as well, such as Can we look at this multi-layer network and can we perform auditing functions? Can we visualize the network? Can we classify the health of the network? And can we take actions to improve it? That means we need to have an understanding of all of the puzzle pieces in all of the layers about what lies beneath the IP layer. And this is a very important concept. If you do not have an understanding of, for example, what it's like to generate a photonic service, then it's very difficult to create a three-dimensional model where you're understanding the entire health of the network. So each one of these is a contributor to the functionality of a purpose-built coherent router. Now, the next thing we need to look at is the integration of the DWDM technology, what we can do to maintain that technology over generations of time and be interoperable along the path. So here's the good news. Congratulations, we have 400 gig interoperability being deployed today. Now, where we're at on the journey, if we look at all of these different standards for where we're going on the journey, what comes after 400 gig? We all know we're going to 800. And then you can see here that the standards are very near completion for 800 gig interoperability. That's a good sign for all of us. And then kind of moving forward, standards for things like beyond 800 gig have started and have a targeted completion date. So as a community, we are working together to solve this interoperability problem and be able to provide this DWDM connectivity. So that's the good news. The thing to be mindful of is the thing in the bottom right. You need to be aware of limitations and trade-offs as you progress through these evolutions. So what we want to be able to do from a lifecycle management perspective, we want to be able to keep this node in the network and avoid forklift upgrade. That means then it has to be forward compatible for what it needs to do and not be isolated into just being a 400 gig node, right? Now there are applications and circumstances where we need to get the right form factor. We're going to talk about that. There's a trade-off between flexibility and cost. And there are times when we have to make a decision what we're going to do. The next is on evolution. Now, the first aspect of evolution is being adaptive. Sienna's talked about the adaptive network for many years now. In this case, we're talking about the adaptiveness of the node. So scale, speeds, what kind of feeds are we going to have? If you look here, the process usually begins with site selection. What I mean by that is every location in the network has a role that it plays, but it's not always the same role in every location. Therefore, we have to look at this site, what kind of traffic comes in and out of this site. Is this site an endpoint? Is this site a hub? Is this site an edge? What function, what role does this location in the network play? Then we start looking about what we need at this site. What kind of capacity, what kind of speeds and feeds do we want? What kind of services and transport functions do we have? The scalability. We're concerning all those pieces and putting them together. This is a very traditional thing. We've done this for decades. And then we come out with the answer, dear Mr. Customer, here you go. You're either looking for, product A, product B, or product C, right? A very traditional model. The question is, has the conversation evolved as we look at the multi-layer node? And the answer is yes. And it looks something like this. We're going to talk now about maintaining that footprint, avoiding waste. So now we're kind of building to the needs of that site while still interoperating and functioning at the protocol level with the rest of the network. So that means I might make a selection to put a router into the network, and as the network grows, there may be growth patterns that were not forecasted. There may be changes in circumstances in the amount of capacity or the functionality that I need on that router. So the idea is that perhaps we can start at one point and then we could add in different pieces of that puzzle to form a next generation version of itself without having to replace it. So the idea there is lifecycle management, and we're going to touch on that more. Sustainability is about energy consumption in many cases. Now, this chart here is a very generic chart for the overall industry on what we're looking at on the power for small form pluggables. You can see that the numbers tend to go up as the performance goes up. So we need to be mindful about what type of pluggables we're putting in to this purpose-built router, and can it withstand the power and the heat requirements of the next generation optic going into it. The next thing is also considering what role we want to play in the network. And this is a very traditional picture about energy efficiency and switching. This has been presented in this conference multiple times in the past if you want to review that material. But the whole concept of at what point in the network do you need this type of node? We don't believe it's in a one-size-fits-all solution. We acknowledge the fact that there are brownfield networks and that each location in the network has its own individual role. So throwing things like optical expressing out the window are not very popular topics in customer networks where they are trying to sweat out their assets and leverage what they have. So if we look at energy efficiency and switching, we want to try to be able to make our switching decisions at the lowest cost possible and be able to evolve it over time if we need to. The other thing on sustainability that we always talk about are cooling requirements, but the problem is, unlike the paradigm shift that took place in the data center, we still have a tendency to talk about things at the box level. And that becomes problematic because it's really about the facility itself, where this box resides, and what else is in the row. So it's really about the cooling of the entire building and what role these nodes will play and how many empty racks are there adjacent to this node and how much power and a cooling capacity do we have at this location. As you move forward with DWDM technology, we need to consider the thermals. And the previous generation of thermal consideration that was used on routers before were all based on gray optics. Actually, they were based on copper. And when you look at it, the thermal footprint that we had talked about when you put in ZR and ZR Plus technology raises the level of thermal density in that location. So we need to figure out the longevity of this router and how it can cool those DWDM optics and how long it can do it for and what is the impact to the neighboring bays around it. So when we're looking at these kinds of things, we want to be able to maximize the efficiency of the building as well as the router itself. Finally, we want to be able to reduce waste. And to do that, we need to think about life cycle management for a second. And these are all relative. They may be slightly different in your situation. But if we look at things like routers and networks, the life cycle can be anywhere from 4 to 5, maybe 5 to 7 years is a typical scenario. For DWDM technology, there's innovation almost every 24 months. There's a new technology coming out. On the photonic layer, it's very different. It's almost like radio base stations, like 10, 15 years, right? So how do we balance this picture in a way that we can maintain total cost of ownership over time? So we need to think about a way that we can move to next-gen optics without having to upgrade the entire and replace the entire router, right? We need to consider the power and the thermals that we're playing with in a way that we can be cost efficient today and maintain that cost efficiency over time. So it's not just about first-end cost, which is still important. It's also about the total cost of ownership over the life cycle, and can you actually extend the life cycle of a coherent router longer to be longer than that of a traditional router. Then We can play Legos and put the pieces together. Again, that's a lifecycle management issue. If you need more ports and you need more capacity, can you bolt them on without impacting the IT and integration of a router? Next, to reduce waste, we want to think about our impact. Again, it's not just on the node, it's on the network. And if you talk to operators, the most important assets in an operator network actually revolve around spectrum, whether it be wireless or across photonic networks. The idea is we want to maximize those assets that we have in the ground, especially the fiber itself, which means we have to take into consideration what is the strength of that fiber? How long has it been there? What grade of fiber is it? And are we able to bring the full capacity of that fiber to build a metro or core network? Now, when we think about that, there's a lot of things that go into place. This is where the analog world starts to come in, because fiber can degrade. It's a physical thing. So we need to think about how can we maximize the throughput of this fiber. And one of the things we want to do is we want to take into account all of the physics and the consideration of the strength of signaling that goes across this, because the last thing we want to do is have to degrade that fiber to a lower rate. For example, in transport, older fiber may have to be degraded to 300 gigs versus 400 gigs of actual throughput capacity. The other thing we'd like to avoid is increasing unnecessary overhead, because in the transport world, when they ask for 100 gig, they mean 100 gig, not 100 gig full of a bunch of headers and a bunch of fat that goes on top with a payload of IP or Ethernet underneath it. They want 100 gig. All right, so if we break it down, we have three major pieces. We have operations, we have evolution, and we have sustainability. This is just the tip of the iceberg. And we're just touching on very high-level concepts here. But you can see that we've been pulling together different ideas and learning from different spaces, and we had that in the keynotes this week. I recommend you go review those topics again to pull all of these pieces together. If you look, all RFPs are almost written in this kind of language, right? If you want to learn more about what lies beneath and the details of how to build something that's different, a purpose-built coherent router, I invite you to come see us at the Ciena booth. We can have a conversation about where this can go and how we can help you in your network. Thank you.